Hello everyone, this is Tristan Morrow and welcome to this short training video for entry-level IT and cybersecurity professionals. In this session, we'll explore Wireshark traffic analysis using a wireless capture file called CWNA underscore chapter 17.pcap. We'll be analyzing two frames, frame 8, which is unencrypted, and frame 136, which is encrypted, while reviewing how each corresponds to the OSI model from layer 1 up to layer 7. Before we dive into the packets, here's a quick overview of the OSI model layers we'll be working with. Layer 1, which is physical, is responsible for sending wireless signals. Layer 2, which is data link, handles MAC addressing and local delivery. Layer 3 is network, and it deals with the IP addresses and routing across networks. Layer 4 is transport, and it ensures data is reliably delivered using TCP or UDP ports. Layer 7 is application. This is where human readable data like web requests resides. First, we'll look at frame 8, which is the unencrypted wireless frame. In this screen, all you would do is click on frame 8, which I've already clicked on. You will find under IEEE 802.11, you'll click on that. And here we will find the source address and the destination address, which are highlighted. The destination is highlighted right here as 009096 BD 7735, and the source, which is 001A 73 3D 67 3C. And these layer 2 addresses are essential for switching, allowing devices on the same wireless network to communicate. Now we'll move on to layer 4, version 4, Internet Protocol version 4, which will be right here. Here we'll find the source address and the destination address. Source is 192.168.100.52, and the destination address is 192.168.100.52. And these belong to layer 3 and are crucial for routing packets across different networks. Now, under the Transmission Control Protocol, or TCP, we'll find the source port, which is 20, and the destination port, which is 1105. And these are layer 4 identifiers, help establish connections between applications such as web browsers and servers. Let's see here. Then we can look at the line-based data, which is over here on the right side, and you can scroll down. You'll see this information right here. Now we'll be moving on to the frame 136, which is a encrypted wireless frame. So you'll scroll down a little ways, and it's right here. First thing we'll look at is the IEEE 802.11, which is right here. And we'll look at the source address again, which is 009096 BD 7735. And the destination address, which is right above it at 001A 73 3D 67 3C. Even though this frame is encrypted, layer 2's information is still visible to allow frame delivery over the wireless medium. But if we tried to find the other IP addresses or TCP ports, they are missing, and that's because it is encrypted using WPA2 or WPA3, which hides layers 3 through 7. Let's see. Just a second. And so we'll go over how this will help you in your IT and cybersecurity journey. So the layer 2 information helps in tracking devices and identifying anomalies. Layer 3 and 4 data are useful in firewall rules, routing issues, and network segmentation. The application layer data lets us verify web traffic, detect malicious payloads, or monitor compliance. And finally, the encrypted traffic shows us that data protection is working, and any analysis here would require keys or a man-in-middle setup for further inspection. And as for the conclusion, to wrap everything up, Wireshark is a powerful tool that gives us a window into the invisible world of network trafficking. By understanding each OSI layer and analyzing both unencrypted and encrypted frames, and you're building foundational skills that are essential in cybersecurity and networking roles. Thank you for watching. Have a good night.